Okay, let's look at these graphs here with this review of features of functions. We're going to start first with the first one that says, is it a function? Remember that the definition of function is for every x, there's only one y. And a lot of you remember doing this vertical line test. If it touches once anywhere on the graph, then yes, it's a function. So we're going to go ahead and say, yes, it is a function because for each x, there is only one y. Now the domain is the x values of our graph. And so we're going to look right here that there's really three little sections of graph that go from here to here. But then notice that right there at that dot, it stops and then starts right up at the next level. And then it starts, goes until the next level, etc. So technically, this actually does have only one domain because it stops and then starts up at the same x value. So I'm going to say right here that my domain goes from negative 1, 2, 3, 4, 5, 6. From negative 6 to 9. Oh, there's an arrow there, so it's to infinity. Now, since the negative 6 has a closed dot, we're going to use a closed bracket right there. So this is only one domain because each little line stops and then starts right up at the same x value. Okay, range. I like to do the min and the max first. For example, the minimum of this graph goes to negative infinity, so it's got no min. And then the maximum of this graph is right there. It's actually the x-axis, which is y equals 0 as my boundary line. So I'm going to say that my range goes from negative infinity to 0. Increasing intervals, do you see how it's not increasing anywhere? The whole graph is going down on each of those little like step-like things. So increasing, we would say never. And decreasing is the entire domain. It's going down from there to there, from there to there. So it's going to match the same domain answer of negative 6 to infinity. Remember that for decreasing and increasing intervals, we always use open brackets. Like there's no such thing as a closed bracket when we're talking about increasing and decreasing. Okay? All right, that one's done. How'd you do? Let's look at the next one. Next one, vertical line test. Yes, it's a function. Because for every x, there is only one y. The domain, see how there's an arrow going forever left? Goes from negative infinity all the way up until 9. 9 has a closed dot. Infinity always gets an open bracket. The minimum of this graph goes through negative 10. And the maximum of this graph has an arrow. So we say that it's going to infinity. And that there's no max. So now that I have my min and my max, I'm going to say that my minimum to my maximum is negative 10 to infinity. Now my increasing intervals. Let me go label this real quick. This section is decreasing, this section is increasing, and this section is decreasing. So there's two sections, always open brackets, that are decreasing, and one section that's increasing. For the section that's increasing, it goes from here to maybe like there. So negative 1, 2, 3, 4, 5, 6. From negative 6 to 2. How's that looking for you? And then the decreasing intervals are going to be from negative infinity up until -6. And then from 2 to 9 is my other decreasing section. How'd you do on that guy? All right, next one, vertical line test. Yes, it's a function. Okay, our domain goes from -4 forever right. So we say that that's -4 to infinity. And it's a closed bracket because of this beginning closed dot. It's an infinity at the end because of the arrow. Range is my min to my max. So for my min, it goes forever down. So we say that that goes to negative infinity and that there's no minimum. For the maximum, it's the boundary line at the top part of the graph. So in this case, it's through 1, 2, 3, 4, 5, 6. And so we can say that the range goes from negative infinity to 6. Increasing and decreasing are always going to be open parentheses. I can see that my graph is increasing first and then decreasing here. There is an interval of constant as well right in the middle. So increasing goes from -1, 2, 3, 4 to 2. And then decreasing goes from 4 to infinity. And then if you did want to write the constant, it goes from 2 to 4. This little section right here. Okay. Now we did this one in class. If you want to fast forward it, domain is in two parts. It goes from negative infinity up to -5, both open bracket because of the open dot and the infinity. And then it goes from -3 to 10. And these are both closed brackets because of the closed dots. Minimum of this graph goes forever, so we would say that y approaches negative infinity. And then maximum of this graph is the boundary line here through 1, 2, 3, 4, 5, 6, 7, through 8. So we say that the range goes from negative infinity up to 8. Increasing interval is going to be this one, and this one. So there's 3 sections of increasing, 1 section of decreasing, and 1 section of constant. Increasing from negative infinity to -5. Increasing from -3 to 2. And increasing from 7 to 10. Decreasing from 2 to 4. And if you want to write the interval constant, It goes from 4 to 7. Okay. This one is also a function. Domain of this one goes forever left, forever right. Range of this one goes forever down, forever up. Increasing is never. Oh, just kidding. There's a little section in there. I just saw it. -1, 2, 3 to -2. Decreasing from -infinity up to -3. And then from -2 to infinity. All right, last one. Yes, it's a function. Domain goes forever left to forever right, -infinity to infinity. Range goes forever down to forever up. Increasing is going to be this section right here, this section right here, and this section right through here. 3 sections of increasing. And then 2 sections of decreasing. This one goes from -1 to 2. And the last one next one is decreasing from -5 to -1. And then from 2 to 4.